Yeah, that's what I heard too.
Breed. So they've been like handled their whole life, so they're super friendly. Because they normally pet store ones they don't get handled very often. But these ones are handled every single day, so they're very friendly. And I was like, it was $25. I was like, you know what? Let's do it. Why not? My brother said he's like the most expensive thing is the vet visit, and I was like, there's no way I'm bringing a gecko to a vet. Like, there's no way.
When one of my dwarf hamsters was dying, I brought it to the vet. They were like measuring its heartbeat, but it's a dwarf hamster, so it's like this big.
Yeah.
So they just set it on top of the stethoscope. Like just stay there. I mean, it was sad, but it was also funny.
Did he die?
That one, she did, but it was kind of normal. The other one died of old age. She would like climb up her cage and then throw herself off backwards. This is not. She was fun.
Yeah, that's what I feel about this. It's like, if it doesn't work out, I at least gave it a shot. Like, he's pretty cute, so his name's Spatula.
Are you talking about a person?
Nope, we're talking about a gecko. Yeah, his name is Spatula, Spatch for short.
This is their happy place. And then I don't use it like this for a while.
I'm really excited for this presentation.
Why the
I noticed last time you were positive emotions.
There's like a running list of stupid stuff.
Oh no.
Steven's so happy.
Mine's
actually not too bad.
Thank you.
I look very concerned.
I hate that picture.
I love it.
Okay, just cross my face off. Everyone else looks great, but not me.
I'll try better next time.
Okay. Oh my goodness. Check out mine.
If the animations do not work on this slideshow, I am going to struggle to explain anything.
John, you look just disappointed.
I know, I don't know what's going on.
Someone wants to ask you stupid questions.
That's tangent. Why did it? I guess I didn't even think about it before I put it on there.
It's my favorite part of the class. You're studying waves, right? Can we please project content to the screen? Okay, well, thank you for the dedicated effort in preparing slides and for coming here and still staying in the course. We are in the CHEM364, and it is a physical chemistry course for interpreting outcomes of instruments for characterization. But achieving this goal is not possible without quantum theory related to wavy nature of electron. Wavy nature of electron is not possible without complicated math, and complicated math is boring. So we are taking a shortcut and getting some minimalistic exposure to scientific computing, which attendees of the class will present to each other and become responsible for the rest of the class knowing their share, right? So there are 6 presentations. the number 7 was last time, and I do not doubt that you are well familiar with Microsoft Windows and PowerPoint, but just in case, it is here. And here are slides from 1 to 6. The presenter approaches and clicks. And when it pops up, there is a little button here to put it on presentation. On the actual screen, it is not blocked, so it is easy to bring up. So about 5 minutes plus whatever takes questions, and we should be finished by 50 minutes. First speaker is Amelia, and she will start from using MATLAB as a calculator, but maybe there will be more than that.
We never know. Good morning, everyone. Okay, so I did my presentation on complex numbers and functions, the definition of argument, and the basic graphics for functions. So complex numbers, obviously it's represented as I, but it can also be irreplaceable with J, and imaginary units are used to create complex vectors and scalars. So in that top right picture, I defined x as all equal integers from -3 to 3, and then took the square root of x, and then it gives you all your imaginary numbers, obviously only for the negative ones. And then in this picture, did 6 plus 4i times 6 minus 4i, we got 52, because it takes that imaginary unit out. And then in this one over there, I did 23.6i squared gives you negative 556.96. For functions, you have to define your variable and then calculate the output of basic functions by typing whichever function into that basic formula. It's pretty simple. So originally I defined y as all variables from 0 to 10 pi. At variables of pi fourths. So here's all of sine, cosine, and tangent of my defined y. And then later, we will graph those same functions. And the definition of an argument is the specific input to the function, also known as the independent variable. When you use MATLAB, or MATLAB's most basic functions, there's most likely only going to be one definition of argument or one independent variable, such as when I define y as those values. And then here are graphs for the sine, cosine, and tangent that was previously defined. And I guess I didn't really think about this when I just put it on here. I was trying to finish my slides. But the tangent looks a little wonky, and I don't know how to explain those jumps per se. But that is all.
Okay, well, thank you. And presentation is open for discussion.
Yes. Stop laughing.
It was a dumb question. I was going to ask why tangent jump.
I already told you I don't know.
Can we go to slide number 3 and discuss the top line? So what are the 3 numbers before column, inside 2 columns, and after columns? It's not tricky. There is no trap in the question.
There's a lot of zeros in there.
No, the top line.
Oh.
Y equals 0 colon pi over 4 colon 10 times pi. What are these 3 numbers?
So y is starting at 0, and then it's every integer from pi fourths all the way to 10.
So pi fourths is increment.
Yeah.
What is the general practice or goal of selection of this increment if you want to represent continuous function? Do you want it to be bigger, smaller?
Smaller.
So how many steps you want to have between first and last, typically.
Infinite.
And in your case, infinity equals to approximately how many?
40.
40. Okay. So what would happen if you take it like 10 times bigger?
There would not be as many jumps.
Perfect. John, your curiosity is satisfied, right? Yep.
I guess I didn't know how to do infinite.
But you can do like pi over 40 or pi over 400.
Yeah.
Right?
Yeah.
Absolute infinity would not work. It will collapse the computer. More questions to Amelia? If no, let's thank her once again. Young-gu.
Yeah.
Hong. Yeah. So, probably it is the please go ahead, hardest and longest talk because it will cover basics of linear algebra to us. I need to take coffee too.
Hi, my name is Yu Hong, and today I will introduce to you how to do various calculus with MATLAB program. Before I start, I will briefly inform you how to download MATLAB. The first you need to go to NDSU MATLAB portal, and you can click Get Started button here, and you can log into NDSU page with Blackboard ID and password, and you are going to be required to create a MATLAB account. And then you finally can download MATLAB R 2019B.
Did you experience any problems in this process?
No, I didn't.
Did you ask your password, your MATLAB password that you created more afterwards?
Yeah. So I reset my password after getting some email. And first, calculus method is derivative in finite differences in MATLAB. Looking at these values, it is simple to do derivative because we all know about the definition of derivative, which is the differences of y values between 2 points over the differences of x values between 2 points. And the same to integration of the function. By the definition of sum integration, we're going to consider the square area between x1 and x2 times height of y1, and so on until x5. This is how to integrate numerical calculus with MATLAB. There was the method of the numerical. This was the method of numerical calculus, and we also can do some symbolic calculus with MATLAB as well. First calculus method is derivative of MATLAB. I found out that it is useful to download symbolic method toolbox application. It's free for every MATLAB users, and it is available in MATLAB webpage. After you download this app, you can start symbolize function fx by typing sim_fx, and after that, you can define fx by putting fx equals 3 times x power 4, and you can set the differentiate function of fx by df equals diff x comma y, and after that, you can figure out dfx by putting df at x itself, and eventually you can figure out the derivative of x by derivative x in x3 by df x df. This is how to do derivative with MATLAB. Of course, you can apply this method to other more complicated functions like sine, cosine, and exponential functions. And now I'm going to show you how to do an integration with MATLAB. We're going to use the same function for convenience, 3 times x power 4. We can start with symbolize fx also by since fx, and we can also define fx by putting that one. And we can set the integral function of fx by putting int f comma x. And we can figure out the indefinite integral of the function. Definite integral function is all the same until the last step. For the definite function, you can figure out the definite function by a definite function of fx by putting int and the range, int f and the range. In this case, it's x1 to x3, so we can put f, comma 1, 2, 3. We're going to talk about the scalar and dyadic product in MATLAB. You might not be familiar with terms scalar and dyadic. Scalar product in vector is exactly the same with dot product that we learned from calculus class. Dyadic product is another type of vector calculation, which is commonly used in quantum mechanics. The characteristics of dyadic product is that it's linear to both operand, and the product is not cumulative. So, to calculate dyadic algebra by MATLAB, therefore, we should know how to do dot product and cross product with MATLAB. So this is how to get a dot product with MATLAB of the matrices of x and y. So we can start with defining vector x by putting x equals bracket 1, 2, 3, and we can define vector y also as putting y equals bracket 4, 5, 6. Now we can get a dot product of x and y by putting dot x and y. Additionally, this period sign means element by element multiplication. So x period times y should be 4, 10, and 18. This is more complicated dot product process with MATLAB that we can do in MATLAB. We can also calculate the transpose vector of x and transpose vector of y. So we can write down a transpose vector with putting prime in the end. And x times y's dot product is the same of the vector of x and y. And thinking of the theory of the linear algebra, x dot times x prime dot product with y and x times x dot product with y prime is not defined because the dot product is not defined in the calculation of two column matrices.
So what happens if you try to do
It
it?
shows an error in MATLAB as
Mhm.
here. But however, if you try to calculate the dot product of y prime and x prime, it shows the results, which is exactly the same with x dot product with y, according to the principle of the dot product of this one. And this is how to do a cross product of x, vector x and y. So we can also start with defining vector x by x equals 1, 2, 3, and defining the vector y by this column matrices, and you can calculate cross product of putting cross any size x and y. And for the last one, this is Dirac notation. It's one of the convenient notation that turns everything in Schrodinger equation into linear algebra in the form of vectors like below. So we can derive this solution of Schrodinger equation more easily with MATLAB. And using with the previous method, I introduced dot product and cross product, all of those. So it's pretty useful to use MATLAB in quantum mechanics and physical chemistry when it comes to calculating complicated equations. Thank you.
Thank you. Okay, presentation is open for discussion. I have about 4 questions, but maybe you have. Next year we should split this logical talk on like 2, special calculus and linear algebra. We just are ready to teach math at college level, all courses. But questions? Anything you are not happy or sounds a little strange?
So for doing integration without like downloading the program, can you just do that in like the finite way? And you showed that be like the only way to do it?
Yeah, that's what I'd say.
Okay. Yeah.
Yeah.
So definitely.
But also you can increase the amount of calculation, but it cannot be as accurate as that. symbolic one. Thank you.
More? Okay. So you did compare numerical calculus and analytical calculus.
Yep.
So it looks from your talk that symbolic calculus is better because it gives nice answers.
Yes.
But so you maybe not highlighted, but implied through the body of your talk that symbolic calculus has some benefits. Other shortcomings and weaknesses of the symbolic calculus. And anyone is welcome to contribute.
It's gonna take more time or more data to. I mean, like, it's more complicated, but it results more. The results of the symbolic calculation is more accurate. So I think there's no weak point of symbolic calculus.
Everyone agrees?
Cannot think about it.
It looks very attractive.
It takes time for the programming.
Other functions that symbolic differentiation will fail with.
Excuse me.
Other classes of functions for which symbolic integration will fail. Did you try to apply symbolic calculus to Gaussian function?
No, I haven't.
What are you expecting? Can you do an indefinite integral of Gaussian function?
I think I can.
You may try and share it with everyone
But if I can show that Gaussian function is an exponential function, which is y equals fx, then I think there's not going to be a problem for calculating Gaussian function as well with symbolic.
Okay. So respected opinion. Everyone agrees? Buys this argument? So I'm not going to argue. Just throw in an idea that by solving differential equations, one often, especially nonlinear, one can come into functions that do not have analytical solution in functions like exponentials, sines, and cosines. There are special functions designed for each equation, but generally there are much more differential equations that do not have answers in standard functions. And then one needs to go to numerical integration. So numerical is less precise, but it is more general. You can try it all the time. Okay?
Yeah.
More questions.
Yep.
Slide number 2. So in the top left, you do have a protocol, range of independent arguments and a range of functions, and then third column is derivative.
Yeah.
Can you make connection between this protocol and what is on the image? Like, what is the function? What is the derivative? Just briefly introduce an example of numeric differentiation. Like the function is x squared, right?
Yeah. So I think these all is x1, x2,
Yes.
and these values y value.
Okay.
So these answers is the difference of y over the difference of x for
Okay. Can you check at least for the first difference?
the first one.
Yeah. first difference.
It's the
Third column. How does this number correspond to these two numbers?
Oh, this is the difference of. Yep, these values are the difference.
Okay.
Y.
Okay.
Value.
And then you multiply it by divided by increment, and you get the red line, right?
Yeah.
Which will be 2x.
Yeah.
Okay. And last question. The rest of talks will be quicker. This one counts as 2 talks. Do not worry. Let's go to the last slide. So you did mention dot product, cross product, and you skipped dyadic product from your discussion.
Oh, what I understood from the internet is dyadic product is the combination of dot product and cross product, and I kind of introduced the rules of dyadic product. That's what I understood.
But let's go to the last slide, and please interpret your white box with Dirac notation. Just read what you see and interpret.
Yeah.
We are waiting a little and suffering a little now, but then if you give us ultrasonic speed.
I think this matrix is the dot product of these two. A cross product.
No.
Is it just multiplication?
It's multiplication by matrix multiplication rules, but instead of row by column, you multiplies column by row, right? And outcome of multiplication of column of phi1, phi2 to the row psi1, psi2 is not a number, not a new vector, but a matrix. So the dimensionality pops up. And it is a very general trick that will be used later. And if you try this thing on the simple examples, which is showing in the next line, so multiplying column by row, it gives a matrix. So
so this matrix is called matrix, which is n times 1. And this is the row matrices, which is 1 times n. So by the principle of linear algebra, the multiplication of these two matrices turns out to n times n.
Yes.
Vector.
Yes. Yeah. Perfect. Yeah. No more questions? Let's thank you especially strongly for giving a very important talk. So, Kristen will speak maybe shorter than you, but her talk is, instead of basics, it is more advanced chapter of linear algebra, which are directly used in quantum theory.
Oh yeah. The first part that I'll comment on is how to create a matrix in MATLAB, which I would presume we'll be doing often going forward. And so there's two different ways you can do it. One is to create your open bracket and then fill in your numbers as you would write a matrix just on paper. And so for each separate row, you hit enter, and until you close that bracket, you're still filling in your matrix. So then an alternative way to do that is open your bracket, and then at the end of every row, put a semicolon, and then you don't have to hit enter. So you can just do one linear equation, and it'll shoot out the same matrix. Saves you a little bit of typing if you want. In order to perform operations on our matrices, we can do this really easily in MATLAB, because when you type in an operation against your defined matrix, MATLAB will perform that operation on the entire matrix without you having to type it in for individual values of the matrix. So for here, I have a couple examples. If you have your matrix A plus 10, that's just a simple addition of your matrix. And then if you have sign of your matrix, again, with a D, you might define matrix. But MATLAB does a good job of performing that operation on the whole matrix. As and you already talked about a little bit, we can do a transpose of our matrix, and the transpose is when you essentially replace your rows and columns in your matrix. And so remember, from matrix A was originally 1, 2, 3, 4, 5, 6, 7, 8, 9, and when you do A prime, which is your transpose, you now have 1, 2, 3 as your column instead of your row. So your diagonal stays the same, but your rows and columns are switched. Next, we have the inverse of a matrix, which is again a very powerful function we use with linear algebra often. This, by definition, is an inverse matrix of A such that A times A inverse is equal to the identity operator, or identity matrix 1. And so we have an official definition, but like I said, A times A inverse should equal 1. And in order to perform an inverse on MATLAB, we have a nice easy function of I and D for inverse. So here I define a matrix X just arbitrarily, and then my inverse of X gets spat out by MATLAB without having to do the complicated linear algebra that often comes with inverse matrices. Next is our determinant of a matrix, which can get really sticky when you get into different sized matrices. By linear algebra, we have definition that the determinant is a scalar value that can be computed from the elements of a square matrix and encode certain properties of that matrix. So oftentimes we do this with a 2 by 2 matrix, and you can do that by hand real easily. But as your matrix expands, that math gets more and more complicated. And so in MATLAB, you can instead define your matrix, type in D, T for your determinant, and it will give you a scalar number. It's important to know that this should be a scalar, so if for some reason you got a vector or a matrix out, something went wrong. So then to get into more specifics of our class, we've been talking about the eigenvalue problem a little bit. And so I have up here how we've seen it already in class. We remember that we used the eigenvalue problem in order to define the future of a wave function. And so I have up there kind of the original Schrodinger equation with the eigenfunctions. But you can translate that into matrix language, as I like to say. And that, yeah.
X is multiplication, or you intentionally want to have X there between C sub K and phi sub K?
Oh, this should be in parentheses. It's C sub K with respect to position, right?
No, it is set discrete numbers. It's not functions.
Oh, you're right. So then it should just be
X should be removed.
Okay, my bad. I must have had that mad in my notes.
I should have noticed while walking through. Sorry, just keep going.
That's okay. So then we can translate that into matrix language, where H is our Hamiltonian, and then, or Hamiltonian, yes. And you get to a point where, did I define it? Oh, I didn't do it here. But essentially, E is our identity operator, and then our H values are going to correspond to our eigenfunctions and our eigenvalues. And so when we switch this to MATLAB, we define our eigenfunctions as, did I write it down? Yeah, eigenvectors as U, and then eigenvalues as V. And then by performing the command EIG of our matrix, it'll give us U as the eigenvectors and V as the eigenvalues. And you can note that these are values since there's only one for the X, one for the Y, and one for the Z, instead of a full matrix.
Okay, I thank Kristen. And the presentation is open for discussion. Anything in this linear algebra chapter that you always wanted to ask but were hesitating to? Can we please go to the slide number 2? So if you do see the program, next speaker can be made on me, because in the program there was a question that was not declared originally. So it is a question to everyone. It's not responsibility of either Alyssa or you or Kristen, but your comment about applying functions to matrices can relate to this additional question in red. Like, what do you expect if you apply exponential function to a matrix? Just share, it is it is not test of your knowledge and preparation. It's more like exercise for thinking. What do you expect if you define a matrix and then apply exponential?
Matrix multiplication. So I think it's a squared would be like a times a for your matrix. Right?
But exponential is infinite series.
Yeah.
Like unity plus x plus a squared over 2 factorial plus a cubed. Right?
Yeah.
Please make your eyes are rather over class and check if everyone understands what you're talking. And if you do not see understanding, repeat it so that everyone gets this idea. I doubt, because when I was in the undergraduate, it took me 2 years to get this idea. If you all understand, you are like 100 times above me, which I welcome, but did you got the idea about power expansion of matrices?
I haven't.
Okay, then ask Kristen once again. You're not speaking to me, you're talking to the class. Your answer is absolutely correct.
Okay.
But now we do have a pedagogical issue how to communicate this idea.
Essentially, you're performing matrix multiplication repeatedly, so you can use a summation to define, say, like a squared plus a cubed, right? Is that what we're saying?
Yes.
Yeah.
Yes.
And so it's essentially the summation of your following matrix, your following powers, which end up being a lot of matrix multiplication. So I guess MATLAB would really simplify that.
And thank you. And if you will finish very soon. So if you see in this red signs, there is a EXP of A and EXPM of A. So what Kristen has explained and everyone promised to understand is EXPM. So matrix form of exponential function. When it's just exponential is expanded into Taylor series, and instead of independent variables, there are matrices. EXP without M means that MATLAB just takes each element of the matrix and then takes exponential of this element. And the result of this operation is drastically different. Yes?
For EXPM of A, wouldn't there be like infinitely many like M's that you would keep?
Right, right. And
So,
it is not our problem. It is problem of those people who programmed MATLAB.
so they'd be able to.
You
handle it to some
truncate
extent.
the series as soon as you achieve convergence. If adding next term doesn't change, let's say, determinant of the resulting matrix.
So they're not going to be results for EXP and A.
There is a result, and we will do it extensively. More questions to Kristen? If no, let's thank her enthusiastically. And Alyssa is going to enlighten us about how to show all these matrices and matrix operation to humans in visual form.
Yeah, now we just go look at pictures, so it's not really. Okay, anyways, so for the first part of my presentation, we just visualize a matrix. So it's just a physical representation of what a matrix would look like. So you can use it in a couple different ways. The first command that is like generally used if you just want like a basic bar graph is just bar of x if your x is your matrix. So I just defined x, and then bar of x will give us a nice pretty picture. I don't know how to change the colors on it, so that's the colors that were provided there. So hopefully I'll learn how to change the colors of it.
So these bars are 1, 2, 3, 3 to 1, right?
Yep.
Okay.
Yep. Nothing fancy, but it just matches with what the matrix was defined as. And then if you want a 3D version of the same thing, you just type bar 3 of x. So this is the same x that was defined on the previous page. You get a nice little look at it, and you can twirl it around and You can see all the different angles of it if you'd like. So that's basically what there is to graphing bar graphs, if you want to visualize a matrix. So if you want to do a function, this is similar to the same thing as what a matrix is. So I realized that I did an exponential function here. I kind of was just go with the flow of whatever I was feeling that day. So this was an exponential function. So I have 10 and then dots. So you treat 10 as just a regular number. And then to the power of x, which x I believe is still the same. Well, x is here. So from 0 to 1 in 0.01 increments. So there's 100 increments between 0 and 1. And then if you type bar 3 of f, it produces a nice little graph. But since you could do bar or bar 3, but since I put bar 3 here, it's not 3D. So when you like to roll it around, there won't be another side to it because there's only one side. So you can do bar, doesn't matter. I just put bar 3. I think that's just what I was in the mood for. So you can do the same thing with 2D functions. So this is my 2D function. So I have sine of x and then sine of y. And so multiple ways to look at these are the nice, pretty pictures. So this was pretty dark. I don't know if you guys can see it, but there's definitely a color change, but it's not very noticeable. So that's the surf command. So if we do mesh, it'll provide you with a nice, same exact thing, but just prettier. And then mesh with C, it gives you a contour map on the bottom here. So you can see the depth and height, I guess, of each of the curves that are represented above. And then waterfall basically eliminates anything below 0. Well, that's what that looks like. And that's it.
Okay, let's thank Alisa. Any questions? Please.
So on your fourth slide, what would happen if you did the 10 without the dot?
It comes out with an error because it doesn't like that. I'm not sure if it would treat 10 as it was supposed to be like a matrix, I guess. I think that's what it would treat it as. I'm not sure, but it doesn't work. Found that out the hard way. I was sitting there I don't know why this isn't working. I think it treats it as a variable, but something other than the constant.
Some way to kind of just describe it.
What?
Some way to just describe it.
Yeah, it limits it to just 10.
Cool.
More questions? If no, let's thank Alisa once again. And next presenter, Morgan, will give us general directions of how to improve qualities of figures. So it will be theoretical instructions. And if there were some difficulties in implementing, it's the right time to share and help each other.
Okay, so the first part of mine is format figures. I just realized that I'm missing a slide. I think I might have emailed the wrong save, but it'll still work. So so to change fonts and stuff like that, there's 2 different ways you can do it. Much easier way that I find is just kind of if it was a Word document. Just go to the home page and preferences, and about midway down, you'll see fonts. And once you go in there, from there you can change the font style, the size, everything like that, colors. And so I was not able to get MATLAB on my computer, so I don't have an example. But that is the first way to do it. And then the second way is to actually use the command line, similar to how we change the labels in our graphs when we were practicing it in lab 2 weeks ago. You can use an example like font size, and then in the blank you can put whatever size font that you would like. And then similar with color, and at the end of that you can attach your R or your G, or you can, if you want to change the shape, the circles to the stars, you can put another letter at the end of that command as well, and that will allow you to change the color or the shape of the line that appears in your graph. And then the second portion was the animations. And so the first thing you have to do is you have to create some kind of plot. So this could be any kind of curve, like some kind of sine curve like that. I know in lab we had one given to us. So you have to name it and you have to save it within MATLAB in your MATLAB folders, and you can open it up from there. A little sugar there. So first you have to establish your parameters in and your max. So once you do that, then you have to sort of label your video. So this line right here is kind of stating that you want to take this file that you have and you're making it into a video. And so file name is just, you type in whatever you name your file. So like I think in lab it was like superposition or something like that. So that's what you type in that place. And then you have to open this sort of video that you're trying to make. And then you start your loop. So then you go from 1 up to your max, whatever you set your max as. And then you can use any kind of constant here. So I just put in B for video, and then use your get frame fig, which is kind of like going to establish the frames for each one. And then the next step is you sort of like add a frame. And so once you establish that you want to make this into frames, then you can adding frames. And then the pause feature, in this place here, you just put the time in between each frame that you want. So if you want a more smooth, animation, you can put less time in between each one. If you want it to be blocker, you can put more time. And then you have to finish up with end, which closes the loops, and then none of the other stuff that you type below that, it won't affect your loop or your animation at all. And then you close the video once you close the animation.
Okay, thank you. Any questions about this theoretical directions? I do have 3 questions, but it's all in one. So, what is movie, or what is animation? Why animation is needed in this class? And third, what to do with MP4 file that is generated by your code?
So what an animation is, it's basically, or a video is basically just like a series of pictures.
Mm-hmm.
So that's kind of why you add the frames. So you basically just put a bunch of frames in a line, and then if you play quick enough, like a little flip book, you get a movie per se. And then the second one was why, right?
Why animation is needed in this class?
So just like the same thing of how we use figures, like rather than looking at things as math or numbers, it's a lot easier to look at a figure. But then if you can actually show the motion of how that is acting, it makes the, depending on your learning, how you like to visualize things.
Because we have a timeline and predicting.
Exactly, yeah.
Okay.
Very time-dependent stuff.
And third one, in your code, if you go back to the slide, it tells video object equals video writer file name .mp4. So it looks like your code will generate MP4 file. What do you do with it?
Well, from there, then you can save it, and then you're able to play it. Like if it's an MP4 file, you can play it with any kind of like QuickTime media player or something like that. So that allows you to like take it out of MATLAB per se, and then you can put it into other programs or documents.
Which programs or documents?
If you wanted to put it into like a presentation or something like that, so you could save it out of that and put it in this. If your MATLAB download worked.
If you, very good. Question number 4. If you would be instructor of this course, which assignment would you design to check if everyone was able to generate these files?
Wait,
if you would be instructor of this course,
okay.
And you, because you already told that this course does need movies, how would you formulate a homework assignment to check that everyone is able to do this movie?
You'd probably have to do a presentation.
And if you do, if there is no time in class for presentation?
I suppose you'd probably have to just email it then.
And if it is a very big file?
You have to find a way to condense it.
What do you do if with your cell phone you catch some fun events, what do you do next?
Record your
Record it. Just do like a screen record.
What do you do with recording after it is done? If you want to share with friends,
You like
you do not send emails with big files.
Cloud.
Cloud, or you put it in social networks, like your Facebook or YouTube, right?
I say, oh, YouTube, you can
Right.
upload YouTube
Right,
videos.
right.
Oh.
So a reasonable assignment would be like to put your generate a movie, put it in your Facebook or YouTube, and share the link. Okay, more questions? If not, let's thank Morgan once again. And last but not least, John will teach us how to program. Right?
Save something
Read
to a
something.
file. So if my animations work, this is going to be wonderful.
If no, you will
not,
upload
I will-
it to your social media.
I think they will. So, what I'm going to be talking about today is writing and reading MATLAB, like from a file. And so basically how to save the file, but then also open it up and send it to different things, such as Excel, which is Excel is the example I gave because I think that's easiest. So this is basically an overview of how to do this. This is incredibly visual. There are almost no words. So I will do my best to explain everything in case you are not a visual learner. So starting out here, there's a lot of this page, but I'll walk you through it. So I define two matrices, X and Y, and that's just kind of to get the definition of some variables done. I then defined X times Y just to add another layer of what you can do. And then I set matrix equal to X times Y. So now I have a defined variable matrix, which is X times Y. You can see that down there. When you type in matrix, it spits out this. Okay, if you move over to the other side, I have a save command, and I think, yep, so you go from there to there, and then that circled piece is the command you want to type in if you want to save a file. So you'll type save, and then minus ACSCII, then you put a space, and then there's two parts to the actual save. You have something that says savefile.txt, and basically the save file is the name of the file you want to save it as. I put it as .txt, so it saves like a text file. That way you can put it into Excel. And then the second part, where it says matrix, is the name of your variable. So like, let's say I'd named this variable pi. Okay, so then you type pi instead of matrix. And this right here, you can write that as pretty much anything you want. Just something you can remember, so when you want to reopen the file, you know, you're not confused what you're looking
Say
for.
that command again, I just can't read it.
So it says save negative ASCII space, and then what you want your file name as, .txt, and then the name of your variable you're saving. And that can be a matrix, it can be a vector, it can be a set of data points. Any of those work. And then if you hit PWD, that'll tell you specifically where you can find this file. And so I hit that just so I knew it was in documents under MATLAB, and that'll be helpful when we go to the next slide. Oh, and so when you save it, you get your little save file up there that you can come back to. So this is Excel. This is what I kind of use the file as. And so here, if you open Excel, you hit open, go to browse. From browse, I just basically took the path that you found by hitting PWD, which is going to documents in MATLAB. And you want to make sure you select all files. If you select, because automatically it's all Excel files and it won't show up there. So once you select that, from there, it will show your save file. Otherwise, if you don't select all except for all files, it won't show up. And so I just double clicked on this and opened it, and you get this window that pops up. So when this pops up, you want to hit next, then next again, and then finish. And then your data points will pop up like that. And this is the matrix I set kind of just in that notation. But again, if you had like a vector or something like that, it would come up similarly. Okay, so finally, back to MATLAB, if you have saved a file, like I previously did in the first slide, I know it's small, so I'll try to explain it the best I can. It will be in the system. So what I did here, I typed in who to see what my variables were. Nothing came up because I didn't have any variables since I cleared my commands. I typed x equals 1, and so I have this variable. Hit who again, show me that my variable is x. So that at that point, my only variable existing was x. Now I type matrix equals load, and then I type this file name. So my file name was savefile.txt, and then the matrix popped up because even though it wasn't defined, once I typed in that, it came up. And so now when I hit who, my defined variables were matrix and x. Questions?
Okay, well, thank you, John. And as he suggested, we may ask you some questions.
What are you doing?
Okay, question. Oh, you wanted the command?
Yeah.
Okay, it's matrix equals load save file.txt. And save file, I just typed that so it's easy to remember that that's like your save file name. And so this is,
Do you need the quotation?
yes, I cannot tell you why, but you can need that. And that I believe matrix equals, that just defines what the name of your variable will be. So I just set it to matrix because that was what it was before.
What is ASCII?
It's a very good question. That is.
Do you look at Wikipedia?
No, I did not.
Any guesses? I just looked while listening to you and listening to Alyssa's question. Well, I know the answer, so I cannot play this Wheel of Fortune.
Is it a what's the word like?
A stands for American. Yes. S,
Scientific,
standard.
American Standard.
Computer, very close.
Computation.
Calculator.
More. Data.
Collection.
Second letter is O. You are right.
Copy.
No. Third letter is D.
Code.
Code.
Okay, American Standard Code.
Collection 2.
Yeah, correct. Inter-exchange. Yeah. So basically, it's text file. Data is text. More questions to John? If no, let's thank him once again. Many thanks to all presenters. From now on, we can use MATLAB to predict future and put moves forward. Right? Looking forward to see you on Wednesday, and meeting is dismissed. Thank you for your hard work. Everyone gets points equivalent to successful homework.
Oh, you can't read it.
Barely. Like